exactly the workflow that I'm presenting, how to build this kind of an application. So initially we'll have the whole data. The data is the complete data that you will have, which consists of the input-output combinations, right? And remember, this is the traditional machine learning discussion that we were having in the last session. So how does the machine learn? How does the model learn? The model learns from the data that you provided. If you don't give the data, the model will not be able to learn. So machines also learn from the historical data. Machines learn from whatever data that you provide. So for the machine to understand that given a review, what is the sentiment, you will have to teach it first. You will have to teach the machine with lots and lots of labeled examples. So you will have to provide lots of examples like, okay, this is the review, this is the sentiment. This is the review, this is the sentiment. Let me write it down. Maybe that will be better to relate to. So, so what you can do, this is your data, and the data will be, you will have a review and you will have a sentiment. Right? So I'll just write it this way. There will be some X and there will be some Y. There will be some X and there will be some Y. So X is the review and Y is the sentiment. Okay. And this is the label data. This is the data that you will train your language model on. Not exactly training. This is again something called meta learning that happens. I told you already that LLMs are already pre-trained. You don't have to explicitly train it, but with some sample data, you can basically include these examples as part of your prompt. That is what I basically meant when I said training. So you will give the machine lots of this label data, review sentiment, review sentiment, review sentiment, so that the machine is kind of able to understand that given a particular review, what is the expected sentiment for your company. Something very similar to what I was showing you as an example yesterday. Yesterday, remember when I was discussing few shot prompting, I discussed the exact same use case where I said that you will give the machine lots of labeled examples. Okay, lots of labeled examples for testing. But in large language models, in LLM applications, it's kind of the reverse. We actually take a much more percentage of data for testing or gold and very few percentage of examples for few shots. Now, what is the reason? Because remember, here we don't have to train the LLM model from scratch because the LLM model is already pre-trained. It's a very powerful pre-trained model that we have. The large language model that we have right now is already a very powerful language model. It's already a pre-trained model, and we do not have to train it from scratch. We do not have to train that model from scratch. That's the idea. We don't have to train that LLM model. We don't have to train that language model from scratch. So that is why, even with some examples, it will be able to learn. Even with few examples, it will be able to do very well. So that is the whole idea. So you take the whole data, you split the data into few shot and gold. So 20% of your data approximately is few shot. 80% is what we refer to as gold examples, and gold examples are like your test set. This is like your mock question paper. Okay, so this is what you will evaluate the model on. The format is exactly the same. Okay, here also you have something called X and Y, and here also you have something called X and Y. The format is not different at all. The format is the same. You have simply taken this data and split into 20% few shot. This is what you will use to kind of fine tune your LLM in terms of giving a good prompt, and this is what you will use to evaluate your prompt. Okay, so after the prompt is built, this is what you will use to evaluate. And okay, when the new review is this, what is the sentiment that the LLM is predicting? And now we will see the predicted sentiment with the actual gold sentiment. Gold examples are like the think of it like the final test data that you will evaluate the model on. So this is a bit of a new part that we are discussing now, how to evaluate a language model. All right. So these are your text label exemplars. Exemplars are nothing but the few short examples. There's another term called exemplars that we use, and this is how it will look like. So text is your X, and label is your Y. I think we are already clear on this. Okay. This is now going to be the text label exemplars. You will combine this with your system message. Find it, there will be a system message that you will have to also write, plus parameters, because there will be prompt parameters like temperature, max tokens, top P, all that. Okay. And these are your few short examples. Okay. And what is the prompt now? The prompt is a combination of your system message plus your text label exemplars. Let's say there are two text label exemplars, U1A1 plus U2A2. This entire thing is basically part of the prompt. Okay, I hope everybody is able to get a sense of this. So you can see that when we design the final prompt is a combination of your design system message, whatever system message that you design, and the few short examples. So in this case, I can opt to decide how many few short examples I take. So here, let's say if I take only two few short examples, two few short pairs, so then my entire prompt will look like system message plus U1A1 plus U2A2. And these two pairs of user assistant examples are basically used to give some kind of direction in terms of how the prompt should behave, how the LLM should behave. Okay, so this is what is used to fine tune the behavior using few short examples. Okay, so once this is done, that's your final prompt, and you will have a new user message, right? So this is how you design the prompt. Now the important part is there are a couple of variables here, right? There are a couple of variables here. The variables here are the system message itself, because there are different ways we can design the system message. The prompt parameters, there are different ways we can decide what values the prompt parameters should have. So we can set different values for the prompt parameters, and also we can also decide what kind of text label exemplars we should have. Even this is the hyperparameter. You can also choose how many examples you should have. Should you have 2 examples, 3 examples, 5 examples? So you can decide how many examples you want to have. How many text label exemplars you want to have, you can actually choose that. So even that is the hyperparameter. You can decide how many examples you want to have effectively. So what you do is, after you try out all the different things, you will, let's say you have a sample prompt. What you're seeing on your screen is a sample prompt. You have designed a system message. You have designed, let's say, 2 few short examples. You have decided what the values will be, and that's your prompt. And you've decided some parameters. So that's your complete prompt that you have. Now what you will do is you will evaluate the prompt. This is the most important part. Okay, you cannot build LLM applications if you do not evaluate. You will only be able to know the performance of your model if you evaluate your model on some unseen data, on some test data. And that is exactly what gold examples are meant for. Gold examples are meant to evaluate your model on unseen data, which is similar to a question paper, and you want to see how that model or how that application is performing on that question paper. So whatever prompt you design, now you take the gold examples one by one. So this is like the X. Again, this is like the new user input. I call it new. Okay, this is the new user input, which is the X. So you take the new user input, you combine that with the whatever the original system defined prompt that I had, which is a system message plus a few short examples. And now you take you new, and this is what becomes the final prompt. You make the API call. This is the API call. We did all this before. We can invoke the chat GPT, the GPT-4 only model, and the model will give a prediction. It will give a predicted label, and the predicted label will be what is the sentiment. Okay, it will give you some kind of a predicted Y. I'll call it YP, and now we will simply compare the YP with the Y actuals. Because remember, we already had the gold example. We already knew the actual sentiment. So the actual sentiment is known. So now you take that new user query, like you take some sample review, and with that you make the LLM make a prediction. The LLM predicts that okay, the sentiment is positive or the sentiment is negative. This is YP, and now you simply compare the predicted sentiment with the actual sentiment, and that is how we get an accuracy score. Okay, so see how we can actually design a prompt. We can design a prompt, and when I say design a prompt, I mean to say design a system message, design your few short examples, design your prompt parameters. So design all of those things, and then you can evaluate the quality of your prompt. So after you design all those things, you can now evaluate the quality of your prompt. You can evaluate the quality of your prompt by measuring an accuracy score, and then you can try out different methods. So let's say you now try to change the system message. So now you decide, let's say you got an accuracy of 80%. I'm just giving a ballpark number, okay? Let's say you got an accuracy of 80% when you did this, okay? So you got an accuracy of 80% when you did this thing, okay? So now what you do, you change the system message. You make some tweaks. You make it a longer system message. Or let's say you try a different prompting technique, like chain of thought prompting. We talked about COT prompting in the last session. So you do something called COT prompting. You try to incorporate more details in the prompt. You try to make it extremely detailed, extremely methodical. Step by step, recipe-based instructions you're giving. You change the system message completely. You change the CRUM parameters. Let's say increase the temperature value a little. Okay, so make it a bit more variable. Outputs to make it a bit more variable. Okay, let's say you change some other settings. Okay, you change some other parameters in the thing. And also, you try to incorporate more few shot examples. You give more examples, not just U1, A1, U2, A2, not just 2 pairs, but you give, let's say, 7 pairs. Because the more examples you give, the more data the language model has to tune itself. The more variety we see. So more data is always good. Not always, not all the time. You need to have too much data, but more data is definitely generally always good. So the more few shot examples you give, generally, it will be able to fine tune better. So let's say in the next iteration, I give more few shot examples, better system message, better parameters. And now I use that to do the prediction. When I give a new user input, the model will predict some sentiment. And this time, the predicted sentiment is very, very close to the actual sentiment. And you are getting, let's say, close to 99% accuracy. So this is how you compare prompt templates. This is basically what we are trying to do when we are designing applications. So we try out different templates, we try out different methods, and then we have some kind of a gold example or some kind of a test set which we evaluate our language model applications against. And if we get a high accuracy, that's the solution that we take. This is the approach that we generally follow. And this is what we do for the classification task. So the slide is very simple. There is not much that is going on here, but this is a generic approach that we follow for all our classification exercises. So if you see the way we will break down the session now, so we'll see a demo, we'll see an example, and then we will see a very, very similar approach even for generation tasks. Okay, so now with this in mind, I hope everyone is clear on this one. So now with this in mind, let us see one application in terms of how to implement this in code. Because once we see a small demo, it will be a lot more clearer as to what is going on. So we have the classification tasks folder, and I'll quickly show you a small demo from there. And the demo is exactly based on sentiment analysis. It's not something very different. We have the same sentiment analysis folder here also. Initial part are a couple of pip installs that you are required to do. So first we need to do a pip install of datasets, and don't worry too much about these things. So datasets is basically a Hugging Face library. We introduced something called Hugging Face yesterday. Hugging Face is a very popular open source community of data scientists, machine learning engineers, Gen AI developers, so anything and everything to do with AI and data. So that entire community, Hugging Face is one of the biggest communities out there. So a lot of people contribute data sets, models, everything there. So we actually have a Python package for that as well. So we can download data sets, pip install data sets, and this way we can actually take data right from Hugging Face, and it's actually getting installed. So now we can do the rest of the stuff. We already did part of this in yesterday's session. You are already able to install the secrets yesterday, and whatever secrets you installed yesterday will already show up. You do not have to do this today again. Okay, so you already did the secrets part yesterday, Azure API key and all this. So this is the same collab, this is the same account that you're using, right? So against the same collab, against the same account, this will come up. There'll be no difference here, right? So I will just load the API key. The endpoint URL and all this is the same. Okay, this is all the same, right? This will not change. This is for me, but for you, remember, you will have to change your endpoint URL. And you already know how to do it. You already know that you can go to view code, you can take the endpoint URL, and you can modify it. Okay, so this is just one thing you need to keep in mind. Just make sure in all these notebooks that I shared, you just go and modify your endpoint URL. Okay, so this is just the basic initial setup that I'm doing. Rest, there is nothing much to talk about. This is the same workflow that I discussed already. And now we will just see a simple code example of the same. So first, let me show you the data. What type of data do we have here? Right, I'm taking a simple Amazon use case, and this is my data. This is my data. All of you can see. So we have the content and we have the label. The content is nothing but the actual review. This is a long review a customer has written. So the content is a long review the customer has written, and the label is basically the sentiment. Is it positive? Is it negative? Is it positive? Is it negative? That's the idea. Okay. And you can see it's obvious that the 0 means sentiment is negative, because I think the third review is talking about problems. The user was not happy about the purchase. The third review talks about problems. So the sentiment is kind of negative for the third review, whereas the fourth review, the sentiment is kind of positive because the label is one. I think the user was very happy about it. Okay, so we already have this data, and see how we already have kind of split our data into training and few shot and gold examples. This is already done, right? So it's already done. So we already split our data into few shot and gold examples. And here we have actually split equally, although in a more real world application, the split will not be equal. So as I told you, you will have a very small percentage of data for few shot, and like majority of your data will be part of gold, because gold is very, very important. LLM application evaluation is the most important part. You need to keep a substantial amount of data aside for evaluating the LLM models, how they are performing. Okay, so here it is already done. You can see the split is already done here. So we have something called example reviews, review examples DF and review gold examples DF. DF is nothing but data frame. Okay, so now that is done. So this is a simple prompt that we have right now. The system message: classify product reviews in the input as positive or negative based on sentiment. Do not explain your answer. Your answer should only contain the label 1 positive or 0 negative. You can see how we are explicitly stating that given the review, please output either this or this. Do not explain your answer. Don't explain the reason why you gave me something. Just output either it is positive or it is negative. That is all we want to see. We just want to see the output, nothing else. You're explicitly specifying that. You're explicitly stating that. Okay, and now we are actually curating the. So we are actually curating this thing. We are curating the examples now. This is a bit of Python that we are doing. So again, I mean, so all that we are doing is we are basically appending the few shot prompt. So you can see we are taking a sample of 4. So all that we are doing is we are basically assembling a few shot prompt with 4 examples. So that is all that we are doing. Okay, we are assembling the few shot prompt with 4 examples. This is just a little bit of Python code that we've written, where you can see we already have something called Amazon reviews examples DF. So we're iterating through all the rows. We are going through all the rows of my data frame, and we are appending the user and the assistant examples. So we already have this, right? So we are simply curating the prompt this way. Maybe if I show you the output, it will be a lot clearer. If you see the output, this is what we curated. So we went through all the 4 rows, and we took actually sample of 4. That's why we created 4 pairs. If you want to see the 4 pairs right now, what are the 4 pairs? User assistant, user assistant, user assistant, user assistant. So can you see the 4 pairs that we got? These are the 4 pairs that we got. Okay, so this is the first user assistant pair, UA. This is the second user assistant pair, UA. This is the third user assistant pair, UA. And this is the fourth user assistant pair, UA. So these are the 4 few shot examples that we have. And at the top, you can see the system message. So this is what I was talking about. This is what you curate. This is part of your prompt design. And this is just iteration 1. Now, let's say with this prompt, I will query the LLM model and I will see what kind of predictions it is giving on the new data. I will evaluate the model. And let's say if I'm not happy, what I will do is I will go and change the system message. I will go and take more number of sample examples. Let's say in this case, I will take 8. I'll take more number of sample examples. And then if you take 8, you will get a bigger prompt. Can you see? If I take 8, I'm actually getting like 8 few shot pairs. So this is something that you have to try out. You have to iterate and you have to try out. You have to try out different examples and see what works generally. Okay, actually this is adding on top of it. So I need to first go and kind of take the few shot and do it again. Okay, yeah. I think I initialize the variable somewhere here. It's actually a list, right? So anyway, let me just do it from the top. Yeah, it's a list. So because I'm appending, so it will actually start from here. So I have to actually, because this is the list. So when I do append, it is just adding on. So even if you change it to sample 4, sample 8 is simply appending to a list. So you have to run this code again. You have to run from here again, and then it will work fine. You can see I'm back to the 4 few shot examples which we originally did. Okay, and now we will look at LLM evaluation. So we have predictions and ground truths. Predictions are basically the predicted sentiments, and ground truths are basically the gold examples. What are the actual sentiments, the gold examples? Okay, so straightforward, and we can let the model work. I'm not taking you line by line through the Python code because I mean this is all basic Python. So you can see what we are doing is we are going exactly what I explained in the theory. So now we are going through every single row of the gold example, and you're taking a new user input. This is the part where you take a new user input. See, this is the gold review. So you take the gold review, which is nothing but the user input, and now inside the try-catch block, you are actually doing a chat completion create. So you already have the few shot prompt, and on top of the few shot prompt, you add your new user input. You add your gold user input, and based on that, you get a predicted response. The response is nothing but the predicted response, and this you continue appending to the predictions list, and you come and at the end, what you do is you go and compare the predictions list with the ground truths list, and you get an accuracy score. This is all that we are doing. This is take a little time because remember we have a lot of text. We have a lot of text, and at the end of it all, you will see an accuracy score. And after you get an accuracy score, what you can then do, you can go back to the system message, you can modify your system message a little, and then you can again come back down and you can see the accuracy score. And this is how you will iterate. This is actually what prompt engineers will do. The next time when we hear the term prompt engineering, a lot of people get confused. Okay, what are they really doing? This is the kind of work they're doing. They're trying to modify the system message. Because remember, in the front-end application, when you're using any front-end application, even something like ChatGPT, which is so ubiquitous now, it's so common in every household now. It's a household name today. Everybody knows it, right? So we have no idea what the prompts are. We have no idea what the system message or the prompt template looks like. We have no idea. We are only giving the user inputs. Okay, but the makers of ChatGPT, they would have spent a lot of time. They would have tried different system messages. They would have also given some few short examples, which we have no idea. We have no idea what kind of parameters and everything they have given. So they would have also done a lot of these customizations, and they would have evaluated their prompts, and they would have deployed the final one. Okay, that's the idea. Very interesting. You're also getting an error code. You can see 400. 400 is an error code which says. This is actually fine. The system will not error out because it's a try-catch block. So maybe there was some review that got errored out due to the content management policy. And if you just see, this is one of those reviews that got errored out. You can see which part where the error happened. You can see content filter was triggered, and which part of the content filter was triggered. Hate, no, this was not triggered. Filtered false. Jailbreak filtered false. Jailbreak was not triggered. Self-harm filtered false. And maybe sexual is filtered true. So maybe this was some abusive comment or something people wrote. Let's say you purchase something on Amazon and you write some abusive comment. So this is the content management thing that was triggered. Okay, but because we are in a try-catch block, only that row will be ignored, and the rest of the record will be processed. Okay, so this is another very interesting thing that you can see. You can actually go and see step by step which of the records are getting ignored. Okay, yeah. Anyways, for the rest of the predictions will work fine. So every new user input is going through the API. We are getting a predicted sentiment, and now we will compare the predicted sentiment with the actual sentiment. And if we get a high score, we can be confident that yes, our prompt is good. We have designed a good quality prompt, which is ready to deploy. So just wait for this to complete in a minute. Let's see, because you have to understand the context. Like the number of tokens is massive. So the moment you start building applications at this scale, and we'll see a big part of this today also. You'll start to see the amount of token counts is huge. We're talking easily about crossing 1,000 to 10,000 tokens now, because there's a lot of text. Every review is very quick actually. We just open it up and see in detail. That's why it's taking time. And it is complete now, and you can see we're getting a 96.774% accuracy, which is quite good. 96.774% accuracy we're getting, which is a pretty good number that we're getting right now. Okay, now you can, what is iteration 2, what you can now try to do is, we can go back and make some modifications in the prompt, and we can again run it, and this is how we can test out our prompt templates. Okay, And if you come all the way down, what we have done is something called a classification report. Now, this is again some people who are coming slightly from a traditional AI and machine learning background can relate to it. So not only can you get the full score, but you can also go back and in a way, uh, find out the class level performance. You can also build something called the confusion matrix. You can see, okay, what is the performance of only the negative class and what is the performance of only the positive class. You can look at things like false positives, false negatives, true negatives, and you can see the class level performance, right? So at a very high level, I'm not getting too much into the theory of all this right now, but at a very high level, you can think of using something called an F1 score, and you can look at the class level accuracy. So here the overall accuracy is 97%, which is anyways very good. But not only can we see the overall accuracy, but we can also see the class level accuracy. This is like a weighted accuracy. F1 score is like a harmonic mean of precision and recall. But anyways, at a very high level, you can use an F1 score to gauge the overall quality of the model on an average. Right? So you can see the class level performance. And why it is important is because, see, here it doesn't, like, maybe it's not that useful because we only have two classes, either is negative or is positive. But then if you have a multi-class classification, if there are multiple categories, right? Let's say typically for a document management system that a lot of enterprises are using, you might have a very, very real world classification task. So you are having a lot of document data. And based on an automated system, you want to categorize documents into different types. Okay, so let's say based on the text of the document or based on the title of the document, you want to categorize the documents into different types. And you have 10 different document types. Okay, type 1, type 2, type 3, type 4, up to type 10. Okay, or it could be also related to support tickets. So you've got 10 different classes of support tickets that the support ticket can be classified into. So based on the ticket message, based on the support ticket message, you want to classify what category the support ticket belongs to. Is it a category 1? Is it category 2? Is it category 3? Is it category 10? So that's the problem that you're trying to solve, let's say. And there you will have an overall accuracy that is fine. But what will be also very important to see is what is the individual class level accuracy. You also want to know that how is the model performing with respect to each of the types. So I want all the types to do equally well. I don't want type 1 to do like 100%, but type 2 to be like only 10%. That is useless. So the classification report gives you a very strong understanding in terms of how individual classes are performing, not just the overall how it is performing, but also how the individual classes are performing. And that can also help you in debugging, and then you can do a root cause analysis and all those things specifically with respect to that class. So if you see, let's say the type 2 type of documents are not getting categorized correctly, let's say the accuracy is coming out to be around 10%, the F1 score is around 10%, let's say, then what you can do is you can now explicitly look at the type 2. What is going wrong? Why is the language model unable to categorize the type 2 documents correctly? What is going wrong? Maybe it could be that, okay, type 2 is very similar to type 4. Maybe the text in type 2 is very similar to type 4, something like that. Maybe there are two products that your company is using which are very similar. So the LLM model is unable to differentiate between what is type 2 and what is type 4. So that's why a lot of mistakes are happening, a lot of false positives are happening. Okay. So and these are very, very good ways to kind of figure out. And maybe if that happens, maybe the next step could be you can combine type 2 and type 4 together. So no need to have them as separate categories. So maybe at the company you decide that, okay, we don't need to have 10 different document categories anymore. So because type 2 and type 4 are getting confused, because they are so similar, because these two products are very similar, uh, we don't need to have separate categories for type 2 and type 4. Let's club them together and call it type 2 4, whatever. Something like that. Type 2 4 combined. All right. So this is demo number 1. Demo number 2 is also very interesting. I'll just quickly complete this second demo and then we can do one exercise. Demo number 2 is very interesting because it's an aspect-based sentiment analysis. And here, what we are trying to do is we are trying to look at not only to predict the sentiment, but we are also trying to predict the aspect. So we are trying to do two things here. We are trying to predict the sentiment and also the aspect. The aspect and also the corresponding sentiment behind that aspect. Okay. So what am I trying to say? Let me take it up with all of you. Let's say, for an example, So what I've done is I've taken it to Amazon and let me just randomly look up a phone here. So I'm just looking up S25 Ultra as an example. And if I quickly take you to this phone, for all these mobile phones, you will see there's a review section. So a lot of customers will buy and they will give. So go to the review section. There's something very interesting, right? So what Amazon will do is they're doing two things. One, they are actually trying to give customers are trying to give an overall review, and customers are also writing comments, right? So when you go and do a review on Amazon, you have to write a text, and then you will give a 5 star or a 4 star, whatever. Now the interesting part is if you look at this person Nihir Shah, okay, what is Nihir Shah saying? What is Nihir Shah saying? Let's see. Okay, maybe Nihir's. Let me look at negative things. Maybe that will be better to see. Like let's see. So we have a person named Lakshmi. So Lakshmi is saying, I'm writing this review after 3 months of usage. In my 3 months, my device power button is not working properly. Okay, so what are the aspects that Lakshmi is talking about? So Lakshmi is talking about the power button, some kind of hardware issue. While using, I'm not treating it like Samsung Galaxy 25. It is like a first copy mobile. I think in India, Samsung is manufacturing cheap mobile for Indian customers. Okay, well, I don't think there's much we can make. So anyways, so what is coming out of this? Two things. One is from the review, we are trying to find out what is the aspect the customer is talking about. So the customer is talking about the build quality or the hardware. Maybe there are two aspects the customer is talking about. One is the hardware. Second is the build quality. The build quality. So somewhere they say, cheap mobiles, whatever, build quality. So you identify what are the aspects the customer is talking about. That is the first part. And the second part is for every aspect, what is the sentiment? I think this customer is negative all through. Okay. The customer is negative all through. Lakshmi would have been happier if the same phone was given in 10,000 rupees. No? Anyways, if you're paying so high for a phone, then you want it to be good quality. So now, let's look at one more. Let's look at one more example. Let's look at one more example. I think something very good about the phone. Maybe he was paid by Samsung. Right? There are a lot of these sponsored reviews, right? Anyways, so Nisha, right? So Nisha has written that, okay, design and display. Okay, I think it's very explicit here. So we can take a slightly more generic example. Look at this one. Look at Kushagra. Kushagra is saying the design, look and feel, AI functionality is top notch. So in this review, what are the different aspects that Kushagra is talking about? So Kushagra is talking about the build quality, the battery, the display, and the software. Because multitasking and AI is part of software. So the aspects that Kushagra is talking about is hardware, software, battery, and display. Straightforward. Actually, he's talking about everything. Okay, so maybe what comes out of this is the hardware or the build quality. So Kushagra is saying the build quality. So from the review, you identify the aspect is build quality, and the build quality is 5 star, and he says pretty good too. So he's not that happy. Let's say S Pen support. S Pen is one of the other aspect, and he's kind of like, let's say, 4 star. Okay, gaming experience. What is the other aspect that Kushagra has talked about? So Kushagra is talking about gaming experience. They said that is 4 star, something like that. So you get the idea of what I mean by aspect-based sentiment analysis. So here, based on a review, first step is you try to identify what are the topics or what are the aspects that have been talked about. What are the different things that are being talked about with respect to the review? And then for each and every aspect, what is the sentiment for that particular aspect? Okay, so it's a very powerful, way of evaluating reviews, not just giving a total sentiment score, but looking at every aspect and aligning the sentiment scores. And the other exciting part is Amazon is already using it. And they would have gone through all these reviews across all the hundreds of customers and they reviewed it. And what Amazon has done, this is a very good use case of Gen AI. Amazon has basically gone and summarized it. So they would have taken all the reviews. There's something very similar to that meeting transcript, no? So we have like what? The entire meeting lasted for like 7 hours, right? We would have easily generated upwards of 100,000 tokens or close to 10,000, 100,000 tokens, more than that. And we would have summarized all of that within, let's say, 100 words. That is what it is. So by going through all the reviews, Amazon has summarized it. That is part number one. Part number two, for every review, it would have identified what are the aspects. I told you, right? And here they have simply summarized the aspects. Can you see? These are the different aspects that they have summarized. So camera quality, battery life, performance. And now you can click on each and every aspect. And I told you for every aspect there's a sentiment assigned. And now you can click on each and every aspect. Let's say something like camera quality. And you can see that in terms of camera quality, how many positive, how many negative. This is aspect-based sentiment analysis. Because we know that every review, which are the reviews that are talking about camera quality, and with respect to camera quality, how are those customers feeling? Not just the overall feedback, but what we want to know is specifically with respect to that category, how are they feeling? Right, so this is a very powerful way of evaluating and collecting feedback. So if you look at it historically this was not possible. Historically, we used to give a long questionnaire, no? Like if you want to collect feedback about the product, what you will say, you will send a form to a customer and you will ask the customer to rate. Okay, like camera quality, how much rating you give, battery life, how much rating you give, performance, how much rating you give, right? But here what we are saying is, you just write one text, you just write one review, and from that we will figure out how you feel about it. And even on these session feedbacks also, like let's say, all these sessions that we do, let's say there will be some feedback mechanism at the end of it. So there also you will be asked. And so here we still are sticking to the same traditional method, right? So you will have to rate, okay, how was the delivery, how engaging was it, right? You will have to rate on different parameters, right? So let's say there will be 5 to 10 different parameters and you have to rate as an example. But the beautiful thing is, imagine you just had to write one review. Just write one review. Don't have to go and rate on every parameter. Just write your review. And based on your review, we will identify what are the aspects that are talked about. And the model will be able to automatically find out the ratings for each of the aspects. So you just write 100-word review. And from that 100-word review, the model will identify, okay, based on the session engagement, the review is this. Based on the contents covered, the review is this. Based on the delivery style, the review is this. So that is the idea. That is the aspect-based sentiment analysis. And these are some very new things that are actually starting to happen. And you can see that animation speed. Not many people talked about it actually. Very interesting. Only 3 customers talked about it. So only 3 customers mentioned animation speed actually. And value for money, you can see. Not many people feel is value for money. Speed, battery life, performance, and all that. AI functionality. Remember, there was a review where AI functionality was there. I'm not saying that this is perfect. Maybe Amazon also has to do some work, right? So this is not perfect. There could have been other things that they could have also included, right? Maybe S Pen and all that is not there. So maybe there could be more aspects. So maybe that's another thing we need to keep in mind. That this is not perfect. Amazon is also, trying out different approaches to make their model better. So just by looking at it, you will realize that this is not perfect. So they've included something like animation speed. So out of 162 customer ratings, only 3 mentioned it. So this is not very useful, right? If you look at it, this animation speed is not very useful to put it. Rather, there are other things that are more important. Like camera battery life is fine, performance is okay, but I think generally what customers also look for is, let's say, charging. I'm just giving an example. Okay, battery life is there, but there could be some other things like, let's say, functionality. Here it's a very broad thing like AI functionality. Only 4 customers talked about it, but maybe a better aspect could have been uh, something like software. General, software and performance and UI and all that. That mention is not there. But actually, we saw a lot of reviews that talk about it. No? I think there was a lot of reviews that actually talked about this thing. See, I mean, this thing like S2500 is very snappy, apps open instantly, higher refresh rate. So this is what we want to see. But somehow this aspect was not captured. So maybe this is bad development on Amazon's part. Whatever. I mean, this they will iterate and they will make it better. So maybe a better aspect here could have been, okay, something like not animation speed, because only 3 customers talk about it, not animation speed, but you can probably group animation speed and AI functionality into one broader aspect, which is, let's say, something like software quality. How is the UI? How is the overall UI? We are talking. I think now they have Galaxy has launched the One UI 7. How is the overall UI in general? Okay. So now moving on to the implementation. This is not very hard. You can all try this out later on, but I'll let me run this for you and show you. This is a sample example, and this time it's a JSON file that I've got here. Okay. The same kind of aspect-based sentiment analysis, but we have to give some examples, right? I told you that to build an application, we have to give some few short examples to the model. So here we are giving some few short examples also to the LLM. So we are also giving some few short examples here. And these are the few short examples that we are providing. You can see. So the sake menu should not be overlooked. So what is the aspect that is being talked about? It is sake menu, which is something to do with food. And the polarity is positive. Right? Great spot, whether looking for a couple of drinks or a quiet dinner. So this is the general review that somebody has written. Okay, after they went some restaurant. This is the restaurant review, it seems like. Okay. And what are the aspects that are being talked about here? Because we have to, this is the label data, right? This is a few short example. Ultimately, in a real world scenario, we want the model to predict what are the aspects. But here we are giving a few short examples so that we are guiding, we are training the model. So based on the review, the few short aspects are the aspects that are identified here are drinks, dinner, and spot. Maybe you can broadly call it ambience, whatever. Drinks, dinner, and spot. Okay, and this can be broadly categorized as ambience. Okay, and the polarity is positive. So identify the aspects, and for each of the aspects, the polarity is positive, positive, positive. Okay, so this is the general idea. But the approach is very similar. You can design the prompt. You can see we are writing a very detailed system message. And in the system message, we are very clearly stating that what are the different aspects that are possible. Okay, so in each review, there might be one or more of the following aspects: food, service, ambience, or anecdotes, miscellaneous. For each review, identify presenters' input, identify if there are any of the four aspects, and assign a sentiment polarity for each aspect. So we are explicitly guiding the LLM that, okay, first you do this, first you identify what are the aspects. And the review can have multiple aspects also, we know that. And once you have identified the aspects, for every aspect you please find out what are the, for every aspect you find out what are the sentiments with respect to that aspect. That's what we will be doing. This is very similar. We will curate the few short prompt. And you can again see that we have used a sample of 4. If you want to change it, you can, but we have only taken one with 4 examples. This is the default one that we have taken. And this is the final few short prompt that we are getting. So there's a system message, user assistant, user assistant, user assistant, user assistant. This is done. And now we will come to prompt evaluation. Very similar to what we talked about. And we can first give the gold examples and we can get the predicted aspects and predicted sentiments, and here we can compute the accuracy. The accuracy will be lower. You can see it's coming around 65% is lower, and this is expected because it's a harder problem. I mean, just in first glance, in case you are having the question, why is the accuracy low? Because it's a little more difficult compared to a simple sentiment analysis. It's a little more difficult because, mind you, you have to get both right. You have to get the aspects right, and you have to get the sentiments right. Both the things have to be correct. Okay, both the things have to be correct. The aspects have to be identified correctly, and for those aspects, the sentiment has to be identified correctly. So both has to be correctly done. So based on a review, you need to correctly identify what are the aspects of the review, and you need to correctly identify what are the sentiments of those respective aspects. So both need to be correctly done. So you can see the example very nicely put actually. You can see the ground truth. This is the ground truth. That means this is like the gold example. Let's say there is one review, review 1, and for that review 1, the actual aspects are aspect 1, 2, 3 in that order. And for every aspect, the sentiments are positive, positive, negative in that order. This is the ground truth. This is what we expect. Right? So this is the ground truth. This is what we expect generally. This is what is expected generally. This is what we expect. Now the thing is, the first set of predictions, if you see, review 1, aspects are correctly identified and sentiments are also correct. This is a correct prediction. A correct prediction is one where everything is correct. The whole thing is correctly done. That is a correct prediction. The second one, if you see, is not correct. Why? Because although the aspects are identified, 1, 2, 3 in that order, this is matching, but the sentiment is not correct, not matching. So this is the incorrect prediction. This is straight away 0. Even the third one is not correct. Why? Because not all the aspects are identified correctly. So the model has only identified one aspect. So this is also incorrect. We can debate over it. I mean, if you're building a real application, you can debate over it. You can maybe give a weighted rating, weighted average you can do. Maybe you can consider some part, or if you want to consider some part of the answer, you can also do that because it's kind of a weightage. But that is the reason why the accuracy is coming up to be low. It's still running right now, but it has to get everything right. It has to get the aspect side and it has to get the sentiment side. It's a harder problem. And what are the ways you can make it better? You can actually write a better system message. You can show it more examples. If you see right now, I'm only showing it 4 few short examples. Maybe 4 few short examples is not enough. Yes, the large language model is a very powerful pre-trained model, and we talked about meta learning in the last session. It has a lot of very good zero-shot capabilities. It understands things very well, but maybe still, if you show it some more examples, it will do better. If you have some more exemplars, some more few-shot exemplars, if you can show it, it will still do better. So these are some of the things that you can try now by modifying the prompts. Okay, I will wait for it to run. And this is the part where I will encourage each one of you to also, oh yeah, I think it's now completed. It's now completed. And now let me see the score. You can see 62.5%. Okay, so as I told you, accuracy is very, very low right now. Okay, accuracy is very, very low right now. And now at this point in time, I will encourage each one of you to also just try this example. Just try this example and see what you're getting. And the overall exercise that we will do now is very similar to that last use case that we discussed. So we already talked about the classification tasks thing. This was the sentiment analysis and the aspect-based sentiment analysis that we saw. And we all understood the workflow well. We all understood exactly how the workflow will have to be constructed. So we take the data, we split the data into examples and bold examples, and we curate the prompt, and then we test that prompt against the bold examples, right? And we get a predicted label, we compare with the actual labels, and we get an accuracy. And we also talked about the confusion matrix and other things. And based on that, this is the new exercise that we will be solving, patent abstract classification exercise. So let me quickly take you through the solutioning, how we are attempting this. Very similar. All that I did is I just went ahead and changed the file name. You can see pip install datasets is where we will take the datasets from Hugging Face, and this is how my dataset looks like. You can see that every row corresponds to a text and a label. The label is basically the under what group the patent is grouped into. Very much like a document categorization, or maybe another real world use case could be how we go and categorize news stories, something very similar to that. Okay, so you look at a use case like Google News. So you've got different types of news story, and based on the different types of news story, based on the content of the news story, you're effectively trying to classify what is the. So based on the different category of the news story, you're trying to classify what is the class of that particular news story. So that's the use case. So something very similar we are trying to do. Okay. So again, we have the how many different classes we have. You can see we can use something called value counts to test that out. 1, 2, 3, 4, 5, 6, 7, 8. So this is the multi-class classification. Unlike the last use case where we had sentiment analysis, it was binary classification. This one will be multi-class classification. Okay, so multi-class means there are multiple categories that we have right now. So we are looking at something like a multi-class classification here. Okay, and we'll try to identify from these categories. Okay, one more very important aspect I wanted to talk about is it's very important to ensure that you have the right quality of data. It's very important to ensure that the data quality has to be good, the data quality has to be strong. And I think if you just look at this current exercise, the kind of data that is given, the data doesn't seem to be very well organized and well balanced, because there seems to be lots of examples of human necessities, but there are very few examples of fixed constructions. And this is an important thing I wanted to clarify. So you need to have a well balanced data. So don't have like lots of examples of one category and very few examples of the other category. Okay, so we need to ensure our data is well balanced, and this way you'll be able to give curate a better quality prompt. Because remember, all this is going to be part of my few short examples, right? All this will be part of my few short examples, what I will use to fine tune my prompt. Okay, so it is like saying that you're showing the LLM model more examples of human necessities category, but very few examples of fixed construction category. Okay, you're showing the language model more examples of the physics category, but you're showing it very less examples of the the fixed constructions category, and that is the problem. So when we talk about fine tuning, when we talk about fine tuning the language model or fine tuning the prompts in this case, right, through few short examples, maybe the LLM will not learn human necessities, fixed constructions very well, but it will learn human necessities very well because there are lots of examples that are used for that. So data curation is a very, very important part. Goes without saying. It's true in traditional machine learning, and it's so much true even in generative AI based tasks. So it's very important to curate the data, fine tune the data properly. So all these are very risks we have even today. Okay. Okay, moving on. What we have done is again we have split our data into few short and gold examples. So, and you can see here in this exercise, I'm actually trying out different types of prompting techniques. As I told you, this is something that needs to be tried out. We have to try out different types of prompting techniques and see which one works. So first we try out a zero-shot prompting technique. You can see this is the system message, and we are very explicitly stating that what are the different categories that you have to group your patent abstract into. So depending on the patent text, these are the total 8 different categories. There are 8, right? 1,